Today, I'm reporting on part of an intervention and associated research with grade 9 township learners, trying to help them to plan an Expo for Young Scientists competition. Now, you're probably wondering what I mean by developing a NOAA, I need the slides, please, a NOAA legitimation. And I'm going to start by explaining that because otherwise it won't make any sense. Then I'm actually going to jump right to the end first and give my recommendations so that I'm sure that I'm not going to run out of time. And after that, I'll come back, explain the intervention as well as the research that I'm reporting on here, which I hope will convince you of my suggestions. So what is a NOAA and knowledge legitimation? I first became aware of this issue when I was running a grade 10 physical science teachers workshop about investigations. And I asked them this question. Now, I thought it was easy. And I expected an answer something like, how does the length of the pendulum affect its frequency? But I was met with silence, after which a brave teacher said, "This is too difficult. You are asking us university questions." I was puzzled until I realized the teachers were thinking I was asking a different question to what I was asking. And recently I came across Carl Mayton's legitimation code theory, and then I understood how to explain this. According to this theory, we legitimize, we value certain kinds of knowledge and certain characteristics of knowers in various contexts. And we tend to do that implicitly, so we are blind to other codes. Now, the teacher was legitimizing a knowledge code. What I mean by that, one that values canonical knowledge, the kind of knowledge you get from books. I was legitimizing a NOAA code, the kind of knowledge where you create knowledge. And because we were each blind to the other, we were speaking past one another. Because in this context, here in the top corner are some knowledge kinds of codes. We can use another form of explaining this. They are ontic or causal questions. Ontic questions have to do with what is, the nature of things. And causal are why kinds of questions. And those kind of questions in this context are university questions. Whereas I was favoring epistemic questions, which generated knowledge. Now, this is the same problem we face when we are trying to get learners and teachers to understand what Expo is about, because school favors a knowledge legitimation, but Expo favors a NOAA legitimation, and we are speaking past one another. So this research that I am reporting on and the intervention is trying to shift the learners towards a NOAA code and trying to understand what does that take. And I'm going to skip first to my recommendations, and then I'll come back to try to motivate them. So when you do practical work, then I could say there are two kinds, a demonstration and an investigation. A demonstration just deals with one state and explains what is happening and why. So for example, very simple, you could take a candle that's burning, cover it with a jar. You explain what is happening and why. An investigation must do that plus more. It must also have at least one more treatment, which differs from the first in the independent variable and so on. Much more cognitive load. Also, the demonstration asks what is happening, why. The ontic and causal questions, whereas the investigation asks epistemic questions. The demonstration is based on a knowledge legitimation and the investigation on a NOAA. And what I would like to suggest is that in Expo, we actually need another competition. I don't know whether it's a totally other one or a division within Expo that focuses on demonstrations. And once the learners are very competent with that, they can modify that into an investigation, but it is a bridge too far for the majority of even higher achieving township learners to expect them to go straight to the no legitimation. And I'm now going to try to explain why I say so by going, first of all, to the intervention. I'm going to describe it quickly, and then to the research that's to do with it. So this intervention is part of a larger intervention where we take 100 learners divided into 2 groups from 5 low quintile schools, and we bring them to the campus for 2-hour sessions throughout the year. And I'm just reporting now on 3 such sessions. Well, it's 6 sessions because it's per 2 groups, and that I ran to get the learners to plan an investigation for Expo. And the 3 sessions focus first of all on brainstorming, and secondly on the scientific method, and then thirdly doing a full example. So in the first session, we first just told them about what Expo is and started getting them speaking about their interests, which they could possibly convert into a project. Then I brought along this apparatus of these 3 different demonstrations, which I was trying to convert into investigations. And for each of them, I conducted a whole class or small group discussion interactively to try to get them to think about these questions. They had printed books, and then after each discussion, they answered in writing what they got out of the discussion. And I'm just going to quickly describe some of the issues that I came on, which is really going already to some of the findings, but I think it's good here. So for example, one of them is about the candle demonstration, which I was trying to push into an investigation. But what I found was, okay, I started with what I thought would be quick little questions that I could just quickly get from them to connect, but were so obvious and easy because it's lower grade work. And then we move forward to get to the aspects of investigation. Instead, what did I find? I got tripped up by the most basic things. I asked, okay, so what does a candle need? Don't know. What does a candle produce? Don't know. So I had to explain about oxygen and carbon dioxide and combustion and so on. And so it muddied the waters and took the effort. So that by the time we got into the investigation, which is what I really wanted to focus on, there was so much else going on. I'll come back to that just now. But for homework, then they had to apply similar kinds of questions to their own topic of their own choice. In the second session, I introduced them to the scientific method. I had 3 more investigations where I brought equipment and photographs and stuff. Again, did the same kind of process, but this time I formalized it by introducing, explaining the concepts of independent, dependent, controlled variables, and focus questions. And after each discussion, they had to put it into this grid, which really forced application of those things. And then for homework, they had to apply a similar thing for their own topic. In the final session, we set up an entire investigation. How does amount of wind affect evaporation rate? Put up the things, and they had a report which they just had to fill in the gaps of to write the entire report to get the big picture of investigations. Also in that session, in small groups, they discussed their own projects, and then a few volunteered, and we discussed it as a group. And then for homework, they had to finish that, planning their thing in this template, their project. So now I get to my research. So I wanted to know what is required, what happens when you try to shift the learners from a knowledge to a knower specialization. These were my 2 research questions. How do their questions change over time, and what issues arise? I'm going to focus on the first one. So 86 of the learners submitted their books, and I extracted the 756 questions that they wrote within there. And that's my focus, but I also wrote my own notes at the end of each of the 6 sessions, and that's also a data source. I'm going to focus on the top one, and this is how I coded it on 2 dimensions. One is the knower knowledge code, which I've already explained, But as I did so, I realized I needed another code as well, and that is to do with logic. Now, I must explain this a bit because we know that our learners' English is not good, and I didn't want really to access their language ability. I wanted their thinking. And so what I did was I was very lenient in deciding whether it was comprehensible and logical. I looked at the entire context, what else was on the page, pictures, other writing, before deciding if I could make out at all what they were saying, then it would be comprehensible, which is a necessary but insufficient condition for it being logical. All right, so what did I find? I found that it changed like this, but that doesn't probably make much sense. I'm going to take one at a time and speak it through. So in the first session, you remember that I had these demonstrations and I extracted the questions they wrote. And we can see that although I was trying to get them to the NOAA legitimation, I told you there was a lot of muddied waters along the way. And so it's not surprising that I wasn't really terribly successful. It was somewhat, but most were within the knowledge legitimation. I hope you can see that in that corner there, we have knowledge, which is logical. And then on the right hand, know, which is logical, and then down at the underneath, illogical ones. And there was a similar kind of spread for the homework. Seems not to be working anymore. Similar for the homework. Then what about the second session? Now here, I forced a NOAA legitimation or a NOAA code of the question. So it's unsurprising that there was a shift there, but can you see that the majority actually were doing it illogically? And a lot of these questions that I found were in fact superficial distortions of questions that I gave in the example. So for example, we did a thing of how does surface area affect air resistance? And so I got a lot of variations of that, of other things with these terms but in an illogical way. What you can see one example that I've given there, which is, oh dear, how does weights affect surface? And then we get to their own things again. Because of the structure, I did shift it towards a NOAA code, but the majority illogical. And you know, I must just point out, even those for which I was successful, it doesn't mean that they were good questions. So I extracted the quarter that gave these successful questions, and I've been working with them for a year since this. And that's a whole other story that I don't have time to tell you now. But it's a long, difficult path, even once you've managed to get somewhat of a shift there. So that is why what I'm saying is that I think that it is too much to expect of township learners to make that shift all the way to asking epistemic questions as is required in Expo. I think we first need to get them a strong knowledge base and also a strong practical, because obviously if they do a demonstration, they must also do something practical, which is also not done much in their schools. We get that to be strong. And after that, we can help them transform that into an investigation. Thank you.
It is 2 eyes.
I didn't see it.
So when your brain goes here, right? At the bottom, right? Those